I am Dr. D. Prince Sahaya Sudherson, Associate Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Today, I am going to discuss about the design of clutch, which comes under the subject Design of Transmission System, subject code ME8651. Before we deal inside the subject, we can see about the course outcome. After successful completion of the course, the student should be able to analyze the concept of design in the flexible drive elements like belt, chain, and rope drives. The student should be able to develop the methods of various types of gears with parallel axis. The student should be able to develop the methods for various types of gears with inclination with the axis. The student should be able to explain the techniques used to industrial design multi-speed gearbox application. The student should be able to categorize the suitable design for cam, clutches, and brakes for automotive application. Design of clutch. Introduction to clutch. It is located between the engine and gearbox. The clutch is disengaged for starting, changing gears, stopping, and idling. When the clutch is engaged, the engine will be connected to the transmission and power flows from engine to rear wheels through a transmission system. Function of the clutch. The following function of an automatic clutch. It can be disengaged. This allows engine cranking and permits the engine to run without delivering power to the transmission. While disengaging, it permits the driver to shift the transmission into various gears according to operating condition. While engaging, the clutch slips momentarily. This provides smooth engagement and lessens the shock of gears, shaft, and other parts of an automobile. While engaging, the clutch transmits the power to the wheel without slipping in ideal condition. Types of clutch. In mechanical engineering, different types of clutches are present. Numerous types of clutches are used in multiple purpose by engineers, although every type has its own advantage and disadvantage that should be addressed by engineers in order to increase the mechanical efficiency of a component. Friction clutch, single plate clutch, multi plate clutch, cone clutch, centrifugal clutch, semi centrifugal clutch, diaphragm clutch, dog and spline clutch, electromagnetic clutch, vacuum clutch, hydraulic clutch, flywheel clutch. Single plate clutch. Single plate clutch is mainly used in lightweight vehicles for transmitting torque from an engine to the output shaft. As per the name of this clutch, it just has a single clutch plate. Multi clutch plate. This type of clutch has multiple clutch plates that are used in transmit power from the shaft of an engine to the transmission shaft of the same vehicle. It is divided into two subdivision. Also, they are wet clutch and dry clutch. A clutch when operates within the oil bath, then it is called wet clutch. On the other hand, a dry clutch operates without cone clutch. The frictional surface is located in this type clutches as a cone. That is why it is named as a cone clutch. Two surface transmit torque through utilizing the concept of friction. The engine shaft consists of a male and female cone. It is categorized under two sections. They are internal and external cone clutch. Uniform pressure theory formulas. P equal to pressure equal to F divided by pi R naught square minus R inner square. Torque T equal to mu F 2 by 3 R naught cube minus Ri cube divided by R naught square minus Ri square. Uniform wear theory. P equal to F divided by 2 pi into R naught minus Ri divided T equal to mu F 1 by 2 R naught plus Ri. Wire. P nominal pressure. F axial force. Mu coefficient of friction between the surface. T frictional torque. R naught outer radius. Ri inner radius. A single plate clutch with both sides effective, it is required to transmit 25 kilowatt at 900 rpm. However, outer diameter of the plate is 350 mm. The maximum intensity of pressure over the friction surface is not to be exceed 0.1 Newton per mm square. Considering uniform wear criteria and assuming coefficient of friction is 0.25, determine the inner diameter of the plate. Axial force required to engage the clutch. Given data: power 25 kilowatt, N 900 rpm, 2 or 350 mm, P max 0.1 Newton per mm square, mu 0.25. Solution: inner diameter of the plate, torque transmitted by the clutch T equal to P into 60 divided by 2 pi n, using the relation T equal to Tf equal to n mu of R1 plus R2 divided by 2. Considering uniform wear theory, F equal to 2 pi P max into R2 into R1 minus R2. Substituting the relation 2 and 1 using the values R2 0.0175 into 2 minus R2 equal to 0.01689. 0.031 R2 minus R2 into 3 equal to 0.001689 by trial and error method. From the trial and error method, R2 equal to 0.136. Axial force required to the clutch F equal to 2 pi 0.1 into 106 into 0.136 into 0.175 minus 0.136 into 2. So F equal to force equal F equal to 665.2 Newton. A multiple disc clutch transmit 50 kilowatt of power at 1400 rpm. Axial intensity of pressure not to be exceed 0.12 Newton mm square and the coefficient of friction of the friction surface is 0.12. The inner radius of the disc is 80 mm and 7 times of the outer radius. Determine the torque transmitted to the given power. Assume uniform condition. Given P equal to 50 kilowatt, N equal to 1400, P max equal to 0.15 Newton per mm square, mu equal to 0.12, R2 equal to 80 mm, R1 equal to R2 divided by 0.7. Axial resisting force per pair of contact surface F equal to 2 pi P max into R2 R1 minus R2. 2 pi into 0.15 into 106 into 0.08 into 0.08 divided by 7 minus 0.08 equal to 2585 Newton. Friction torque per pair of contact surface Tf equal to N mu F R1 plus R2 divided by 2, T equal to P into 60 divided by 2 pi n equal to 12. A cone clutch with absolute friction lining transmit 25 kilowatt at 600 rpm. The coefficient is 2.25 and the maximum intensity of pressure equal to 0.25 Newton per mm square. The semi-cone angle is 12.50. The outer diameter of friction lining is 250 mm. Considering uniform theory, determine the inner diameter of the friction lining, the face width of the friction lining, the force required to engage the clutch. Given data, P equal to 25 kilowatt, N equal to 600 rpm, P max equal to 0.25 Newton per mm square, mu equal to 0.25, alpha equal to 12.50, 2R1 equal to 250 mm. Torque transmitted by the shaft T equal to P into 60 divided by 2 pi n. Frictional force Tf equal to 2 pi mu divided by sin alpha into P max into R2 into R1 minus square, R1 square plus R2 square divided by 2. Using the two relation equating to the equation, we will get trial and by using the trial and error method, we will get R2 value 107.44 mm. Inner diameter 2R2, 2 into R2 now we got the value 107.44 equal to 214.88. Force required engaged in clutch F equal to 2 pi P max into R2 into R1 minus R2. Substituting all the values, we will get the force equal to 2964 Newton. This data is referred by these following books: Machine Design Volume 2, Design of Transmission System by Jalaluddin, Machine Design by R.S. Kurmi and R.J.K. Gupta, Design of Transmission System by T.J. Prabhu, Design of Transmission System by V. Jayakumar. Thank you.